Imagine standing on the Earth, gazing up as a massive, colorful canvas drifts silently across the sky. For millennia, this was only a dream, until two French brothers harnessed the simple science of hot air. Our journey today explores this gravity-defying marvel. How did the ingenious, yet simple design of the hot air balloon transform from the world's first successful flight technology into a beloved modern recreational and scientific tool? And what essential scientific and environmental conditions govern its very existence? The true birth of aviation took place not with wings, but with a cloth bag and a fire. This brings us to the beginning. In 1783, amidst the French Enlightenment, brothers Joseph and Étienne Montgolfier, paper manufacturers, noticed smoke rising. This led them to capture and heat air. On September 19, 1783, they launched the first living passengers, a sheep, a duck, and a rooster, in the aerostat Revelin. A mere 2 months later, on November 21, the first untethered human flight took place in Paris, piloted by Pilatre de Rogier and the Marquis d'Arlens. This spectacular event was a defining scientific and human achievement, instantly becoming a symbol of man's conquest over nature. Early military uses quickly followed, utilizing balloons for observation. The earliest designs were delicate, but the 1960s saw a crucial modern revival, primarily through the work of Ed Yost, who pioneered the use of propane burners. This leads us to the way it works. The hot air balloon operates on a fundamental scientific principle. Warmer air rises in cooler air. Air becomes less dense when heated. The key components are the envelope, made of lightweight, strong ripstop nylon, the burner, fueled by propane, and the wicker basket. The burner heats the air inside the envelope. According to the ideal gas law, heating the air causes it to expand, making it less dense than the surrounding air. To generate enough lift to carry a basket and passengers, the air inside must be heated significantly, often hundreds of degrees warmer than the outside air. Control is the fascinating constraint. The pilot cannot steer left or right. Their primary control is altitude. To ascend, they fire the burner. To descend, they allow the air to cool or open a large vent, a parachute valve, at the top of the envelope to release hot air. Pilots navigate by ascending or descending into different air currents. Beyond function, the balloon carries significant symbolism and design. In its early days, it was a profound symbol of wealth, fashion, and scientific conquest. Today, the serene, silent nature of balloon flight makes it a potent metaphor for surrender, new perspective, and freedom, rising above the busyness on the ground to gain clarity. The basket, traditionally made of wicker, is chosen for its toughness, flexibility, and energy absorption, essential for smooth, or occasionally bumpy, landings. In modern-day use, the hot air balloon is overwhelmingly a vehicle for recreation, tourism, and competitive sport. Festivals like the annual Albuquerque International Balloon Fiesta celebrate the beauty and adventure of the craft. Specialized long-distance variations, including hybrid balloons, are also used for record-breaking transoceanic and global flights. A successful, safe flight is entirely dependent on climate and conditions. This is why flights often take place right after sunrise when the air is cool and the atmosphere is most stable. Wind, the most critical factor. Ideal surface winds are calm, typically under 10 miles per hour, with moderate winds aloft, less than 25 knots. High winds make launch and landing extremely dangerous. Temperature, cool air is ideal. In hot weather, the balloon needs much more heat to generate the necessary lift because the density difference between the inside and outside air is smaller, putting more strain on the equipment. Precipitation and visibility. Rain, snow, and low-hanging fog or clouds are all no-fly conditions, as they can weigh down the envelope and severely reduce the visibility necessary for safe navigation and landing. From a backyard experiment with fire and fabric to a global icon of serene flight, the hot air balloon has endured for over 240 years. Its power lies in its beautiful simplicity, a timeless marriage of physics and adventure that continues to inspire us to look up and dream of floating on the wind.